Okay, now the systems we're going to solve algebraically, except the first equation has both x and y squared, meaning that it's a circle, and the second equation is a line. But we have y is equal to the negative x plus 5, so I could rewrite the first equation in the system without the y. So instead, I'm going to bring down the x squared plus, instead of y squared, I'm going to put what we have y is equal to, the negative x plus 5 squared, and then equals 13. So we've recopied this exact equation, except instead of the y, we put negative x plus 5. We still brought down that squared outside the parentheses so that it's the same as the original equation. Now, before we could solve, I need to simplify this part that has a squaring the binomial. How do we square a binomial? Yup, we're going to do the boxes. So I have negative x plus 5, negative x plus 5. So I get x squared, because the negative times the negative is still a positive. Positive times the negative, so we get negative 5x, negative x times 5, negative 5x, positive 25. So x squared, when I combine these two terms, negative 10x, and then the plus 25. So here I could bring down the x squared, and then in place of the binomial squared, I'm going to bring down what I got when I squared it. Off to the side here, just came in that place, equals 13. Now I'm going to simplify. X squared plus x squared is 2x squared. Bring down the negative 10x. Same line, I'll subtract 13 on both sides and get plus 12 equal to 0. So now I have a quadratic equation set equal to 0 that I can now solve for x. I have this 2 in front of the x squared, which could make things difficult, but if you notice, we could divide both sides by 2. So now we'll get rid of that leading coefficient, because I'll get x squared minus 5x plus 6 equal to 0. And now I have a simple quadratic equation that's add multiply that has a 1 in front of the x squared. So you could use the add multiply or sum product, or you could graph this polynomial and find the two roots where the graph crosses the x-axis. I'm going to get that. I could do, hold on, negative 6 and positive 1. Nope, that doesn't work because it has to multiply to positive 6. Negative 3 and negative 2. That'll multiply to positive 6 and add to negative 5. So when I solve, I get x equals 3, x equals positive 2. So those of you who did that straight into the calculator, this quadratic right here would cross the x-axis at x equals 3 and x equals 2. I originally did that to move things up because for each of these x values, I now need to solve for y. So I'm going to go back up and use that linear equation, y equals negative x plus 5, but I'm going to replace the x with 3, and here negative 3 plus 5 will be positive 2. So our first solution is when x is 3, y is 2. And now my other solution, I'll plug in to y equals negative x plus 5. I'm going to plug in 2 for x and get that y is equal to positive 3. So when x is 2, y is 3. So if we were to graph this system, which you could do to check, you would see that it crosses at 3, 2, my first solution, and 2, 3, the second solution. Okay, again, you do not have to write it as ordered pairs.